Hello, everybody, and thank you for joining me. Before I'm jumping into the topic of today, profiling JavaScript applications, let's take a hypothetical thing, something that never happened to you at all. So you're sitting in your office and you are working on your development mean machine, and you're writing your code and you're creating your application. And the application runs very smooth and fluid on your laptop or on your desktop machine at work. So what do you do? You push that application into production. Now meet Mark. Mark is one of your users, and it is trying to get into your application using not a development laptop or something that has a lot of good hardware. And the first thing that is going to see is probably some spinner or loader that you created. So he's waiting and waiting and waiting, and then the application loads and it tries to navigate to a different page, and the navigation quirks. It looks a little bit weird. And then he's interacting with your drop-down that you created, and you're so proud of it. And you get the right side of the drop-down and not the left side that works on your machine. And you know what the users are going to do when they see such apps? So you at least tried and you created an application, but you never tested for performance and you never profiled the application. And on our development machines, it's very easy to see that the performance is very good. We are running on localhost and everything is running smooth and fluid. But in the real world, things that you're creating not always run as expected. And doing profiling is hard because we're not doing that at all. We don't have any cycles of performance. Ship to production, and we expect that the users will give us some user testing and see the application works as expected. But that's not the real world. So the idea of this talk is, first of all, to understand how the browser works and why we get performance issues. And then we will understand how to create a profile session or scenario. And in the end, hopefully we'll make our users happy because we won't have any performance problems. So you probably ask yourself, who is this person in front of me that is currently talking? So I'm Gil Fink. I'm the CEO of Sparksys. Sparksys is my own company. We have only one employee. He's sitting here. I'm a GDE, Google Developer Expert in web technologies for 5 years. I was also a Microsoft MVP for 13 years, but lately I've stopped getting that award. I even wrote a book called Pro Single Page Application Development back in 2014. The book is still selling. I don't know why, because it was written with Backbone.js, the father of all the component libraries that we are using today. But the principles of single page applications that were written in the book are still relevant to today. So what we're going to do in the next 35 minutes. First of all, I'm going to explain how browser render web pages. Why is that? Because once we understand the problems or where we get the performance hits, then we can measure those hits and understand how to analyze the application and how to then tune the application and create better performance. Then we'll talk about the measurement, how we measure things, and then we will do a profiling process together in order to understand how this process works. So let's start with the browsers. Let's understand how the browsers are working. But before we are talking about browsers, let's talk about devices. As I said, we started with our development machine, and in the development machine, we have a great CPU and GPU, and we have a screen, and the browser, whenever it needs to do something, it needs to be aligned to the refresh rate of the screen. That means that the screen is refreshing for something like 60 times a second, which means we have 60 frames per second. That means that the browser needs to produce each and every frame that it is creating in 16 milliseconds. 1 second divided by 60, it's 16 milliseconds. In the real world, it's supposed to take something like 10 milliseconds because browsers have their own overhead of management. Now, if we're falling frames, we will get the something below 60 frames per second. You will see that the animation is quirking a little bit, or things aren't working smooth as expected.
The pixel pipeline is divided into 5 different parts: JavaScript, style, layout, paint, and composite. Let's understand each and every part of the process. The first part is JavaScript. What's going to happen is the JavaScript that needs to handle some work will run, meaning that somebody clicked on a button in the screen and something needs to run as the handler for that button. And then the work that is being done in JavaScript will result in some visual change. If it results into a visual change, we are going to move to the next phase, which is style. If it's not, then we did some calculation and nothing happens on screen. Now, CSS animation transition and web animation API are also calculated in this step. In the second step of the pixel pipeline, which is called style, the browser is going to create the CSS DOM. CSS DOM is an object model that is created to represent for each and every element the CSS rules that should be aligned to that element. How does the browser know how to do it? Of course, you're writing your CSS with CSS selectors. It is going to use the selectors, the rules that you created, and then align and calculate the style for each and every element. The third part of the process is called layout. In the layout, the browser is going to calculate how much space is going to be needed for each and every element on the screen. It's going to do the process left to right, top to bottom, which is the web layout model. And it is going to do it according to the CSS rules that it calculated in the style step. Now, after the layout occurs, the browser is going to paint all the pixels into the screen. That means it draws the visual part of the text, images, videos, and everything else into the screen. Last but not least, in the process, the composite step. The composite step, whenever you're doing something like z-index and you're enforcing some layers or of elements, then the browser needs to draw the elements according to the layer that you provided. So if some element overlap another element, who is going to be on top of who? And this step is very fast because it's happening on the machine graphic processing unit on the GPU. And then all the calculation is done and we shipped all the frame. The entire process happens for all the frame to be produced, one frame to the screen. Now let's talk about reflows. A reflow is some change, a visual change requires a new layout of the page. For example, you resized the browser, you added an element to some grid, you removed an element from a grid, you changed an element position inside your page. All of those things require change of the visual layout of the page, and because of that, what the browser is going to do is run the entire pixel pipeline flow from all the 5 steps that we talked about earlier. Now, another process that might be triggered by the browser is Repaint. In Repaint, you're creating a visual change but you don't need to recalculate the entire layout again. What I mean by visual change that doesn't need to have some layout effect or something like that, it's things like I change the visibility of some element, or I change the color of an element or its background or anything else. These changes do not affect the layout, but they affect how things are painted on the screen. That means that the pixel pipeline will run, but without the layout step. Now, whenever layout or reflows or repaints are running, this process is something that you don't have any control of it, because the browser will trigger that process, and these processes are expensive. That means that whenever you're losing frames or producing less than 60 frames per second in your application, it's because reflows and repaints are running. Changes without reflows and repaints also can occur. Something like I'm calculating some stuff, but I'm not changing anything visual. That means that the pixel pipeline will run without the layout and paint, and it will run smooth and very fast. Now we understand all the moving parts of how the browser is going to render pages. So let's try to understand what we are measuring. What we are measuring is different parts of the application, or different parts of things that happen inside our application. All those parts are represented in Core Web Vitals. What are Core Web Vitals? This is something that Google created. Google is using its crawler, and it scrolls on top of most of the websites and web applications today. And they are measuring performance. And they are measuring all those performance using Core Web Vitals. The measurements in Core Web Vitals include a lot of moving parts, but the main three things that we measure in the application are LCP, FID, and CLS. Let's talk about those things. So let's start with LCP, or largest contentful paint. This is the biggest part that is going to be rendered on the screen. It affects the loading of the page. That means that if you have some big image or video or something like that, or big text, and this is the largest contentful paint that the browser is going to produce, this is the thing that is going to affect the loading of the web page. If you're producing the largest contentful paint below 2.5 seconds, you're in a good place. Above 4 seconds, that means that your loading time is very, very poor, and you need to refactor. The second measurement is called FID, or first input delay. That measurement measures interactivity. That means that if I click on a button, I'm getting a response at less than some value. The best values are below 100 milliseconds. Okay, then when I clicked on the button, under 100 milliseconds, I see something happen on the screen. Above 300 milliseconds, it's poor interactivity option, and you need to refactor your code. The third main thing in Core Web Vital is CLS, or cumulative layout shift. That means how fast you are creating your visual stability, or how the visualization in the web page looks like. The most thing that you're going to measure in CLS is probably animation. You need to produce animation below 10 milliseconds each and every frame. We talked about it earlier. And if you're doing more than 10 milliseconds a frame, then you are going to drop a frame, and in the end, your animation will look very, very junky or quirky. So we understand what we are measuring. Let's understand, or let's talk about our tools of trade. What we're going to use in order to create filing or do the filing sessions. The first tool that we're going to use is part of the developer tools. It's called Performance Insight. It's a new experimental feature inside Chrome you can use it, or you can use the performance tab, which is the main tool that we're going to see today. So with that, let's talk, or let's see a profiling session in action. So I'm moving to a web page. Let's take a look at the web page. The web page is called Profiling React Apps, and I'm going to use React underneath in order to explain all demos that I created. And as I said, there is a problem in this web page. So if I know that there is a problem, for example, in the loading of the page, I can open the developer tools by pressing F12, and I can go to one of the two tools that I talked about, Performance Insight or Performance. Let's start with the Performance Insight because it's experimental. It's a new tab in the developer tools, and let's try to measure the page load. So I'm running that measurement, and let's make it even bigger. And you can see that it outputs a lot of data. On the left side, we have a timeline with all the things that happened. Page loaded in something like 57, less than a second. But we have hints of problems in the page. For example, you can see in the Insight tab here that we have a long task. And that long task affected the loading of the application. What you can see in the long task is that the creation of some element was an expensive function call. Okay? I wish that we will get more than that, but let's try and run it again. Maybe we'll get better insights. Again, it's experimental. Okay, so we have two long tasks now, and let's look at the long task here. No, that's not the task I was referring to. No. So I'm not getting any details about the performance problem that I have in the insights right now, because as I said, I'm working on my development machine and it runs very fast. Let's try to use the performance tab and see the loading of the page. Okay, so I'm running the loading of the page, and you can see that we have that exact long task again here. Okay, and it is appearing as a red rectangle, and we did 380 milliseconds of scripting there. And if I open the bottom up tab, I can see that what affected the performance of the tab, or what took almost 280 milliseconds, is something that is called slow. What is slow? Slow is a component that is doing some calculation. Let's see it in our development environment. So this is slow. It is creating a big array, and it is reducing that array into a number. And this calculation, I don't know if I can affect that calculation at all. Maybe I need to run this algorithm, maybe I don't need to run this algorithm, or maybe I can optimize it, but this algorithm is affecting the performance of the page, okay? So what I need to do is I need to figure out how to solve this problem, or how to make this calculation in a better shape in order to solve the performance problem. But sometimes you don't have any way to solve this problem, because I need to do this calculation. But my manager says that the page is very quirky and works very strange, because things aren't working as expected. So what I'm going to do is I'm going to test or collect the data again, but this time let's clean this tab. This time is saying that producing or changing this label because of some text that I'm searching, it runs very, very slow. So let's try and analyze that. Okay, so I'm writing something here and I'm pressing the button and it is very slow. It's not running very fast. And again, now I stop everything and you can see that every time I clicked on the button, this is what's happening. We have some long task that is running. And this long task affected the performance. And again, it's slow. Slow was rendered. And slow is this component. Okay, let's take a look at the components again. We have slow here. And we have search here that handles the search. And we have the title that is being changed by the pressing of the button. Okay. Now, because now I'm trying to figure out what is the problem here. The problem is that whenever I'm setting the value here, the first profiling component re-renders again and again and again, and that's not a good thing to happen. Okay, this is the problem here. So as a detective, I need to figure out how to make the re-rendering or not enable re-rendering after the calculation. I don't want that this calculation will run again and again whenever something is changing in the web page. So how can I do that? I can solve it using React Memo. Okay, so this is something that is going to memorize the algorithm that I ran, and then I'm going to go again and measure all the things. Let's measure the things here. Again, after everything, after all the change. And what you can see here is the timeline is very, very smooth. Everything runs very fast, and I don't have slow anymore inside my bottom up of all the things that are happening. Okay, so let's talk about what I've done up until now. Okay, so I did a profiling process. The profiling process is a process that has a few steps. Once you're doing that, you're going to make everything happen. The first thing that is going to happen in the profiling process is the establish baseline. In the establish baseline phase, what you're going to do is I don't know if you noticed, but I'm running in incognito mode. I don't want to affect the application with some extensions in my browser or to affect the application at all. Another thing that I'm going to do whenever I want to establish a baseline is probably create a new branch, call it performance refactoring or something like that. And this is going to be the baseline of the application before I'm starting the process of profiling. Then what I did was I collected the data. I ran the performance tab, I ran the performance insights, and I looked at the data and tried to analyze the results. Like a crime scene detective, a CSI detective, I'm trying to analyze the results and trying to understand why the performance was poor. Then I'm trying to make a suggestion of how to refactor, or how to change the app or the code, and I tune up the application, and then need to test and measure again whether the change that I did happened, or did it degrade the performance or increase the performance of the web page. If it didn't, then I'm going to run the cycles of everything again and again and again. And if I manage to tune the application, then I'm in good shape and good for me. everything works as expected. So let's take a look at another example of profiling, and let's do the profiling process by ourselves. Okay, so I'm going to move to a different page called color. As I said at the beginning of the profiling session, I'm going to establish a baseline. So I'm running in incognito mode. Probably I created a new branch or a label or something like that in my source control, and now I'm ready to go. So the first thing that you're going to do is, of course, test and measure, collect the data. How do you collect the data? Again, let's refresh the page and then profile the loading of the page, and let's see what happened. I collected the data. Let's try to analyze it. In real world, problems won't jump into your bottom up like it did in my code, because my code is very simple. In real world, you need to look at the things that are the total time that they're running are very high. For example, the decimal to hex here, or compile code that I can't affect it, and search for things that I can affect. For example, I know that I created the color component, so the color here is probably affecting the performance of the web page. So let's move to the code. After I analyzed and I understand that decimal to hex is the problem, let's take a look at decimal to hex. It's a function that is being called here to set the background color of each and every circle. And it is being called 3 times, decimal to hex on red, on green, on blue. Red, green, and blue, these are the values that the component is getting in order to paint the circle. So now I understand that decimal to hex is something that is happening 3 times for each and every render of the color component, and also that it affects the performance of our web page. Can we do better? So of course we can do better, and maybe we can, I don't know, change how we produce the content. For example, instead of using decimal to hex, in CSS we have an RGB function, and that RGB gets the values of red, green, and blue. So I don't need decimal to hex here in order to do the same thing. And I don't need any calculation. I will just send the RGB function as the background color. Let's save it, and let's test and measure to see if this thing really affected the web page. And now, again, we're testing and measuring, seeing whether everything works, and you can see that the timeline is very, very thin as opposed to the previous timeline, and we don't have any code that we created at the top of the bottom-up tab. Okay? The first place here is this thing, but it's 1 millisecond, that's not affecting anything. So we test and measure, we see that the tuning of the application worked as expected. Now you can finish the profiling and we can say, yeah, we made it. Now we can merge the branch that we created into the main branch, and we can move on with our life. So let's summarize what I said up until now. Performance problem will happen because we're running on very, very good development machines, and we are not looking or finding any performance problems in our application. In most of the places that I've been to, there is no profiling sessions during development time. So I'm suggesting to add the profiling sessions into the development cycles that you're producing in your company. And this will help you to find performance problems during the development time and not by your users that will complain to you. Don't wait that the users will complain. Create better applications with profiling performance sessions. I want to thank you. If you want to follow me, I'm at Gil Fink at X, Twitter, whatever. And if you have any questions about this talk, I'm here. Any questions? Okay, so thank you very much for having me here. In 1 hour, I'm going to present the quick workshop. If you want to come and listen to that workshop, it's I think 1:40. And have a nice day, and thank you for hosting me.